Page 7 of integration. We're going to review first the different derivative rules that you know, because integrals are just the opposite of derivatives, so we're going to review derivatives. So when you have a constant, like a number like 3, what's the derivative of that? 0. If you have a number times x plus c, what's the derivative of that? M, right? The mx becomes m and the c becomes 0. What about if you have x to the n? We just reviewed that. It's the power rule. It's called the power rule. And you end up with nx n to the minus 1. If you have cu to the x, remember that the constant just stays out front, and then you take the derivative of the function u. If you have u plus v, which is called the addition rule, you just take the derivative of u and you add it to the derivative of v. What if you have u times v? It's called the product rule. And basically you just have the derivative of u times the function v plus the function u times the derivative of v. What if you have u divided by v? Then it's the quotient rule. And then you have u dashed x vx minus u x v dashed x, all divided by v squared x. What about when you have the function f of u, where u is a function of x? This is just a fancy way of writing the chain rule. So you would take the function, the derivative of f with respect to u, and then you would multiply that times the derivative of u with respect to x. It's called the chain rule. Derivative of e to the x is just e to the x. Derivative of e to the f of x would be e to the f of x, and then you multiply it times f dashed of x, chain rule. Derivative of log x, natural log x, is just, the derivative of natural log x is 1 over x. The derivative of natural log of a function, f of x, is f of x, and then you multiply it times the derivative of the function, chain rule. If you have something that looks like the power rule but with a function inside, you multiply power by the power n, and then times the function, times n minus the product, the power of n minus 1, and then you take the chain rule, you multiply by the derivative of what's inside. Derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent is 1 over cosine squared x. Okay. Now, we've just reviewed all the derivatives that we know. Now we're going to talk about the integrals, which are just the opposite. So these are the integrations that we will do in the course, where c is the integration constant. We talked about c in a previous lesson. So if you have the constant k, the integral of the constant k would be kx. And then every time we take an integral, we can check to make sure it's the integral by taking the derivative of it. Remember, we are always adding the constant c, because whenever you take the integral, you don't know what the constant was before you took the derivative. So if you take the derivative of this, the derivative of kx is k, right? So that's correct. The derivative of c is always 0. The integral of x to the n is going to be x to the n plus 1 divided by n plus 1. If we take the derivative of that, we would have n plus 1 times x to the n divided by n plus 1. Yeah, that works out. Remember that the derivative of e to the x is e to the x, so the integral of e to the x is e to the x also. Oh, remember we need to write plus c for these two. The derivative of what is 1 over x? Ooh, it's log, right? So, log. Okay. The derivative of log, natural log x, is 1 over x. The derivative of sine x is cosine x, so. And the derivative of negative cosine x is going to be sine x, because remember the derivative of cosine is negative sine, so derivative of negative cosine is positive sine, so makes sense, right? And that is it for this page. Page 8, let's apply some of these rules. You can always check your integration by taking its derivative to see if you get the original function. That's what we were just doing up there, remember? We often have to carry out multiplication or division before we integrate because there are no product or quotient rules like in differentiation. So let's take this polynomial here and find the derivative of that. So the integral of that. So the integral of x to the 4th is x to the 5th over 5. The integral of x squared is x to the 3rd over 3. The integral of x is x squared over 2. The integral of 2 is 2x. And then we just put in the signs that are above it because the signs are maintained. Okay, and then plus c at the end. The integral of 3x to the, or e to the x minus 1 over x. So the integral of 3e to the x would be 3e to the x. The integral of 1 over x is log x, right? Plus c. The integral of 1 over x, square root of x, plus 4 over x. So I'm going to rewrite this. So it's x, instead of x to the, it's x to the negative 3/2 plus 4 over x. So I'm going to take the integral of that. It's going to be negative 3/2 plus 1, which would be negative 1/2, negative 2. Okay, and then the integral of 4 over x is 4 natural log of x plus c. The integral of x squared is x cubed over 3. The integral of plus 3 over x is plus 3 natural log of x. The integral of 5e to the x is 5e to the x. The integral of 1/3 x cubed is x to the 4th over 12. And the integral of 4 over x is 4 log x. 2. Integrate with respect to x. So we're still just integrating. You can imagine that there's integration signs here. The integral of 3 sine x is negative 3 cosine x. Remember, the derivative of cosine x is negative sine x, so the derivative of negative cosine x is going to be positive sine x. And this would just be minus 2x, right? The integral of this would be negative cosine x minus 2 sine x plus e to the x plus c. Oops, I forgot plus c here. Forgot plus c here. Okay, I forgot plus c here. All right. Now here's what they were talking about before. Remember when they said that since there's no product or quotient rules for integration that you need to multiply things out. We used to do this for derivatives too when we didn't know the product and the quotient rule yet. So we'll say x squared minus x, divide each of these by 3, and plus cosine x. Now let's take the integral of these. So it's going to be x cubed over 9 minus x squared over 6 minus or plus sine x plus c. Okay. Number 3. Let's see, the integral of that. X cubed over 3 plus 3x squared over 2 minus 2x plus c. And then this would just be 2e to the x. And then we could rewrite this as x to the negative 2. So raise that to, okay, I'm not sure if this is right. So let's take the derivative of x to the negative 1. It would be negative x to the negative 2. Yeah, that's right. So whenever you're not sure about it, just take the derivative of it and see you get the right thing. Alright? And remember, I was just using these rules that we wrote up here. Okay? That was it for page 8 and 7.